Okay, so Trig Basics, Unit 7, Day 1. So this unit's going to be kind of split up since we have midterms. So we'll do a couple sections, take our midterm, and then we're going to just continue. So some of this stuff will be on the midterm, just so you're aware of that. So let's go through this. So Pythagorean theorem, we've done this before. I'm going to just go through it fast. So the formula is a squared plus b squared equals c squared. A and B are your sides, C is the hypotenuse. So let's use that to find x in example A. So A is 4, B is 8, C is x. And you could switch A and B if you wanted to. So A squared plus B squared equals C squared. That's 4 squared plus 8 squared equals C squared. Or you could put x squared, I don't know why I didn't do that. Which is 16 plus 64 equals C squared. So that's 80 equals C squared. Now we're going to square root both sides. C equals the square root of 80. Now we just have to break down that radical and simplify it. So I'm just going to make a factor tree out of 80. So 2 times 40 is 80. And then 2 times 20 is 40. 2 times 10 is 20. 2 times 5 is 10. So I got all my prime factors there. Circle my pairs. And I'm going to pull out my pairs. So I have 2 pairs of 2. So I'm going to pull out 1, 2 for each pair. And then the 5 is left, so that just goes back inside the radical. Then 2 times 2 is 4. So that's 4 square roots of 5. Cool? Let's do example B. So this time, we're not finding the hypotenuse, we're finding A. So A is x, B is 22, C is 24. So it's x squared plus 22 squared equals 24 squared. So that's x squared plus 484 equals 576. Subtract that 484 over, you get x squared equals 92. Square root both sides. Make our factor tree. That's 2 times 46, which is 2 times 23. Circle those two. So this is x equals 2 square roots of 23. Okay? Alright, so special right triangles. You have the 45, 45, 90 triangle. You have a 30, 60, 90 triangle. So I'm just going to go through a little proof to show you how to get the 45, 45, 90 triangle if we ever forget how to get it. Okay, so we're going to start with a square. Now, on a square, the sides are the same. So I just put these lines right there to indicate that those are congruent. Those are congruent sides, they're the same length. Okay, and then that's a right angle, obviously, because this is a square. So if that's a right angle, that means that this right here is also a right angle. And then half of that is 45 degrees, which is why that is 45 degrees, which would make this one up in the corner also 45 degrees. Okay, I should have labeled that, but this right here is also 45 degrees. So label that. I can't figure out how to get this to stay on there, so just draw that in, and then it can go away. Okay, so that's 45, 45, 90. Now the sides are the same, so I'm just going to label those sides x. Now I'm going to use Pythagorean theorem to find the diagonal. So that's x squared plus x squared equals c squared. So that's 2x squared equals c squared. Then I'm going to square root both sides. The right side's easy. That just becomes c equals the square root of 2x squared. And then the square root of 2x squared, the square root of 2 can't do anything. But we know the square root of x squared, it's x. So I'm going to pull out an x. So that means c equals x square roots of 2. Okay, so we just found this right here. This is x square roots of 2. Now I've solved my 45, 45, 90 triangle. My 2 legs are x. My hypotenuse is x square roots of 2. Okay, so let's just label this down here. So my one leg is x, the other leg's x, the hypotenuse is x square roots of 2. Cool. We're going to use this a lot, so make sure you understand this. Now let's look at a 30, 60, 90 triangle. So now instead of starting with a square, for the 30, 60, 90 triangle, I'm going to start with an equilateral triangle. If it's equilateral, that means all the sides are the same. And I'm just going to call these sides 2x. Instead of x on the 30, 60, 90 triangle, we're going to call the sides 2x. Okay? Now, all the angles are also the same. It's equilateral, so all the angles are the same. So they're all 60 degrees because they have to add up to 180. Which means that that little angle right there is half of that, so that's 30 degrees. Okay? So if that's half of that, then I can split the bottom in half, and that piece right there just becomes x. Do you guys see that? Hopefully, and then that's a right angle right there. Okay, and again, I can use Pythagorean theorem to find the height of this triangle. So that's going to be x squared plus b squared equals 2x squared. So that's x squared plus b squared equals 4x squared, because you have to square the 2, square the x. Subtract the x squared over, so you get b squared equals 3x squared. Square root both sides. And you get b equals the square root of 3x squared, which is b equals x square roots of 3. Okay. Now I'm just going to go through and I'm going to label these. So my shorter leg is x, because that's the one opposite of the 30 degree. So the angle, or the side opposite of 30 degree is x. The side opposite of the 60 degree is x squared, so 3. The hypotenuse is 2x. Okay. Hopefully that makes sense. If it doesn't, ask me in class. I will show you and I'll explain it to you in person. Okay? So we're going to save this stuff for class because we have a lot to go through, and I think that as long as you guys get that basic concept, we can save this for class and then we can go through examples and we'll solidify it a little bit more there. Okay, so let's go through this. So trigonomic functions. A trigonomic function is a function whose rule is defined by a trigonomic ratio. A trigonomic ratio compares the lengths of two sides of the triangle. And then the Greek letter theta is used to represent the measure of an acute angle in a right triangle. Okay, so first, every time when you have a right triangle and you're asked to find sine, cosine, tangent, whatever, I want you to label your sides. So the one opposite of the right angle is always the hypotenuse. If you look at where your theta is and you draw a line, wherever you hit, that's the opposite side. And then the other side is the adjacent side. Okay, I think this should be review. I'm not really sure though, so we're just going to keep going through it. So, SOHCAHTOA. We're going to use that to find our sides. This is just something you need to remember. So this helps you remember that sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. And I like to write it like that. So it's sine is opposite over hypotenuse. It's really easy to see that. Cosine is adjacent over hypotenuse. Tangent is opposite over adjacent. So if we're going to find sine of theta, that's opposite over hypotenuse, which is A over C. If we're going to find cosine, that's adjacent over hypotenuse, which is B over C. And if we're going to find tangent, that's opposite over adjacent, which is A over B. Okay? Now we have to get to the reciprocal functions. So sine, cosine, tangent, those are your main functions. Reciprocal just basically means these are the opposite ones. So sine is opposite of cosecant. Cosine is opposite of secant. Tangent and cotangent are opposite. So tangent and cotangent are pretty easy to remember because they both have tangent in their name. Cosine and secant and sine and cosecant, those are kind of easy to get mixed up. Just remember, you always have to have an S and a C. So if it's sine, the opposite is the one that starts with a C, because sine starts with an S, cosecant starts with a C. So sine and cosecant. And then cosine starts with a C, so it's the one that starts with an S. So cosine and secant. Okay, if that doesn't work for you, you need to come up with some little trick to help you remember which is which. Okay, so cosecant is 1 over sine, which basically means I just have to flip sine. So that's hypotenuse over opposite, which is C over A. Secant is 1 over cosine, so I just flip that. That's hypotenuse over adjacent, which is C over B. Cotangent is adjacent over opposite, so you just flip it, or it's the opposite of tangent, so you just flip it, and that's B over A. Okay? Again, I'm just going to save these for class because I think that will benefit you the most if we do this in class. So remember to take the quiz. I'll see you guys tomorrow.